By the end of this video, you will know how to take derivatives of exponential and logarithmic functions. First, here is an example of an exponential function. This is e to the x. Since anything to the 0th power other than 0 is 1, you get 0, 1, typical point on an exponential graph. And since the base of this function is e, if you plug in 2, you'll get e squared. If you plug in -1, you'll get e to the -1. This is the graph of e to the x. It's an exponential function. The question is there a function that has the property where the function and the derivative are one and the same thing, i.e. f prime of x and f of x are the same? The answer to that question is yes, and the function is e to the x. The derivative of e to the x is itself e to the x. Example 1. Find the equation of the line tangent to e to the x at x equals 3. Well, we need a point in order to find the equation of the tangent line. And if you plug in x equals 3, you get e to the third. So the point is 3, e to the third. You also need the slope to get the equation of the tangent line. And the slope to any graph is the derivative evaluated at that point. So the derivative of e to the x at 3 is e to the third, because the derivative of e to the x is e to the x. So the slope is e cubed. Therefore, the equation of the tangent line is y minus y1 equals slope times x minus x1. That's the equation of the tangent line to the graph at x equals 3. Example 2. Find the derivative of e to the 2x. The derivative of e to the x is e to the x. Derivative of e to the 2x is e to the 2x times the derivative of what's inside. That's just chain rule. The derivative of 2x is 2. The derivative of 4 times e to the x is 4 times the derivative of e to the x. It is itself. The derivative of 5 times e to the tan x will be 5 times e to the tan x times the derivative of what's inside. Because the derivative of e to the x is itself, the derivative of e to the tan x is itself times the derivative of tangent of x. In the next example, we have product rule. X to the 6th times e to the 7x. The derivative of x to the 6th is 6x to the 5th times e to the 7x left alone, plus 7 times e to the 7x, which is the derivative of e to the 7x, times x to the 6th left alone. It is customary to put the number in front, like I've shown you here. The last one's kind of a complicated problem that has chain rule in it. You have a square root of e to the sine of x plus sine cubed of e to the x. First thing you want to do, rewrite this problem as a square root as being a power of 1/2, and rewrite sine cubed of e to the x as sine of e to the x cubed. Now you can take the derivative using chain rule. The first thing is the 1/2 times the whole inside to the -1/2. That's just taking the derivative of something squared, or square rooted, times the derivative of what's inside. The derivative of e to the x is e to the x. The derivative of e to the sine of x is e to the sine of x times the derivative of what's inside. Plus, this is actually, I'm going to be using this when I take the derivative, 3 times sine of e to the x squared times the derivative of what's inside. The derivative of sine is cosine, times the derivative of what's inside, which is e to the x. Your final answer, I'm just cleaning it up a little bit. In the denominator, you'll have a 2, and you'll have the square root of this stuff because that's a negative exponent. So you get cosine x e to the sine of x plus 3 e to the x sine squared of e to the x cosine of e to the x all over the square root of that stuff. That's the end of page 1. For page 2, now we're going to look at derivatives of exponential functions, but this time the base is not going to be e, it's going to be something else. I'm using 5 for an example. Does the derivative of 5 to the x just equal 5 to the x? Not quite. Here's why it is what it is. Set y equal to 5 to the x, the function we're using. Take the log of both sides, log base e. then you have to remember your log rules to do well in this part of your calculus class. There's a rule that says the log of something to a power, the power comes down. So what you get is the ln of y equals x times the ln of 5. Haven't done any calculus yet. That's just a log rule from Algebra 2 and Pre-Calc. Now, I'm again going to use something from Algebra 2 and Pre-Calculus. I'm going to go from this logarithmic form to exponential form. If you have log base e of y, which is what ln is, going to exponential form, you'll get e to the x ln of 5 equals y. You may need to review how to go back and forth from logarithmic to exponential form. So this is now in a form which we know how to take the derivative of, because this is no longer 5 to the x, it is e to a power. And the derivative of e to a power is itself times the derivative of what's inside. And the derivative of x ln of 5 is just ln of 5. Just like the derivative of 6x is just 6, so the derivative of 7x is just 7. The derivative of ln of 5 times x is just ln of 5. Now this thing here is actually just 5 to the x in a different form. So your final answer when you take the derivative of 5 to the x is not just 5 to the x. You also have to multiply by this ln of 5 to compensate for the base not being e. Example 1. 6 to the x cubed. The derivative of e to the x is e to the x. The derivative of 6 to the x cubed, 6 to the x cubed, times this compensator to take into account that you're not base e, you're base 6, and then times the derivative of what's inside. Example 2. This involves product rule. The derivative of e to the x is e to the x times the derivative of what's inside times 8 to the secant of x left alone, plus this time e to the root x left alone times the derivative of 8 secant of x. That'll be 8 secant of x, ln of 8 to compensate for the fact that you were not e to the secant of x, you were 8 to the secant of x, and then the derivative of secant of x, which is this. That's the final answer, you're done. Next one involves quotient rule. You have e to the cotangent of x over 9 to the x to the 5th. Well, the derivative will be low d high, low, 9x to the 5th, times the derivative of what's on top. It'll be e to the cotangent of x times the derivative of what's inside. The derivative of cotangent is negative cosecant squared. Minus high d low. Here's high. The derivative of low will be 9x to the 5th times ln of 9 to make up for the fact that it wasn't e as your base, times 5x to the 4th, which you can't quite see there because it got lopped off. All over the denominator, 9x to the 5th squared, which is 9 to the 2x to the 5th. That's what happens when you square 9 to x to the 5th. Your final answer, there is a 9x to the 5th here, here, and squared down here. So one of them cancels, leaving just negative e to the cotangent of x. Now this term also has an e to the cotangent of x, so it's negative e to the cotangent of x times cosecant squared plus 5 x to the 4th, which is lopped off here, but you can see it now, times ln of 9. This 9x to the 5th canceled. This one canceled. And one of these canceled, leaving just 9x to the 5th. Here we are on page 3 of the examples. We're going to learn how to take the derivative of a logarithmic function. And first you need to learn how to take the derivative of just ln of x. What is the derivative of ln of x? You set y equal to ln x. That's what you're trying to take the derivative of. Then you go from logarithmic form to exponential form, which is e to the y equals x. That's exponential form. This you can take the derivative of using implicit differentiation. The derivative of e to the x is e to the x. The derivative of e to the y is e to the y dy dx. And the derivative of x is 1. So dy dx equals 1 over e to the y, but e to the y is just x. So the derivative of ln of x is just 1 over x. Now, this is why that is so unusual. When you take the derivative of x cubed, you get an x squared. When you take the derivative of x squared, you get an x to the 1. When you take the derivative of x to the 1, you get x to the 0, which is just 1. If you take the derivative of x to the negative 1, you get an x to the negative 2. X to the negative 2, you get x to the negative 3, and so on. There's just this one gap that's filled in with ln of x. If you want to get x squared, x, 1, x to the negative 2, x to the negative 3, x to the negative 4, you just use a polynomial. But if you want to get 1 over x as your derivative, you have to start with ln of x. And that says guessed, not quest. My handwriting is still not any good. Next, the derivative of ln of 8x is 1 over 8x times the derivative of what's inside, which is 8. And that cancels to 1 over x. The reason you get the same derivative of ln of 8x as you would of ln of x is because the ln of 8x equals the ln of 8 plus the ln of x, and the derivative of ln of 8 is 0. If your function is ln of cosecant of x, you get 1 over cosecant of x times the derivative of what's inside, and you get a cancellation. If you are taking the derivative of this product, you get the derivative of e to the 5x is 5e to the 5x times the other term left alone, plus e to the 5x left alone times 1 over cosine times the derivative of what's inside, and sine over cosine is tangent. Last, if you're taking the derivative of ln of x to the 5th, you get 1 over x to the 5th times 5x to the 4th. You get 5 over x after the canceling. And you should figure out why using log rules. The last subject that is addressed by this video is how to take the derivative of a logarithmic function that's not base e. The easiest way to see this is just to use the change of base formulas. Change log base 5 of x into ln x over ln of 5, which is just a number. Then when you take the derivative of log base 5 of x, it's the same as taking the derivative of ln x over ln of 5, which is the derivative of ln of x is 1 over x times 1 over ln of 5, because that's just a number. So example 1. If you take the derivative of log base 8 of sine of x, you will get 1 over sine of x, because the derivative of log of x, ln of x, is 1 over whatever's in there, times 1 over ln of 8. That's to compensate for the fact that you're not base e, times the derivative of what's inside. And the reason this says cotangent of x is that cosine over sine is cotangent. Example 2. The derivative of 5 to the x times log base 7 of x is 5 to the x times ln of 5 times log base 7 of x left alone, plus 5 to the x left alone times 1 over x times the compensator 1 over ln of 7 to take into account that you're not base e, you're base 7. I'm going to leave these other examples for you to consider on your own and finish this video now. I hope it's been helpful to you. I'll see you in class.